Hi, I'm Victoria Brackley. I'm a PhD student at Victoria University in partnership with Swimming Australia. And in this presentation, we thought we'd share with you some of our pilot findings from exploring the effect of polo drill swimming on freestyle kinematics. Many of you would be aware freestyle, also termed front crawl, is the fastest and most efficient form of human locomotion through the aquatic environment. This has led to extensive research on the biomechanical requirements for the freestyle technique, especially looking at the upper limbs. However, there's been surprisingly little research on the specific practice approaches required to acquire and improve these biomechanical qualities. Training observations and coach interviews have illustrated that swimming coaches typically prescribe practice approaches that involve breaking the stroke down or decomposing the stroke. Such practice tasks are typically referred to as drills and prescribed within a part-whole training approach. So for example, the full freestyle stroke may be reduced into an arm drill whereby the breathing action is removed, in order to help swimmers focus on their upper limb positioning and coordination. So this particular drill I just described is often referred to as polo drill or head-up freestyle, and as the name implies, it resembles a polo player. In Australia, this drill has been identified as one of the most commonly prescribed freestyle drills within the high-performance setting. And as I briefly mentioned, the objective of the drill is to improve the hand position and coordination in the entry and catch and pull phases of the stroke. Studies have confirmed that movement solutions biomechanically vary between the full freestyle stroke and drill swimming, as you could see in the previous example of polo and freestyle swimming. However, key movement and performance characteristics expected to be improved by drill swimming has not been assessed. And further, even though drills that decompose the stroke may facilitate with some skill learning, there's a debate within the skill acquisition literature whether the skills acquired during such practice approaches are transferable to the movement responses intended to be improved in competition. This leads me to the aim of our study, which was to explore the biomechanical effect polo drill swimming has on the full freestyle stroke. Specifically, we wanted to determine how temporal performance variables and kinematic parameters might differ in the entry and catch phase of the stroke. So the entry and catch phase is understood to be an important phase of the stroke as it establishes the foundation for efficient and fast freestyle. Further, one of the intentions or objectives of polo drill swimming is to improve the hand position within the entry and catch phase, so that's why this study just focused on this stroke phase. For this study, 5 well-trained freestyle swimmers volunteered to participate, and this included 3 male and 2 female. To enable the identification and tracking of anatomical landmarks, 19 black skin markers were affixed on the right and left side of each participant. The experimental protocol took place in a 4-lane 25-metre level deck indoor pool, and a 6-metre long calibration frame was constructed and used to calibrate the swimming volume, and this contained 70 calibration points. And the frame was videoed, and later the swimming movement was videoed using 8 stationary SwimPro cameras and recording at 30 Hertz. So on the picture here, you can see that we had 4 camera frames around the calibration frame, and within each one of those camera frames, there was 1 camera above water and 1 camera below water. The experimental procedure was set up to represent how swimmers perform drills in training. So swimmers swam 300 metres broken into 2 25-metre laps of polo drill swimming, followed by 2 25-metre laps of freestyle swimming, and then this was repeated 3 times. And swimmers just swam at their normal pace they would in training. Post data collection, anatomical landmarks were digitised on both the right and left side of the swimmer for over 1 stroke cycle. The direct linear transformation method was used to perform the 3D reconstruction, and the data was filtered using a second-order Butterworth filter. and cutoff frequencies range from 3 to 8 Hz and were chosen based on residual analysis. The temporal variables calculated included stroke length, stroke rate, swimming velocity, and stroke duration. And the kinematic parameters calculated included finger velocity, elbow angle, trunk inclination, and the vertical displacement of the shoulder and the hip. So for the statistical treatment of the data, we used a paired t-test. And due to the small sample size, the Schwarzer-Wilk test was used to verify that the data was normally distributed, and the effect size was calculated using Cohen's d to describe the magnitude of difference. So looking at the temporal parameters, we found significant difference in the stroke length, stroke rate, stroke duration, and entry and catch duration. Whereas looking at the kinematic parameters, there were no significant differences in the upper limbs. However, the hip vertical displacement, the hip horizontal velocity, and the trunk inclination showed significant difference between freestyle and polo drill swimming. So, as expected, polo drill swimming caused the trunk inclination to increase, and a consequence of this is that it caused stroke length to decrease and stroke rate to increase. The entry and catch phase duration also decreased, and this may suggest that when polo drill swimming, the swimmers were able to enter the propulsive phase of the stroke sooner. Whilst there were no significant differences in elbow flexion from a group analysis basis, individual analysis showed that 3 out of the 2 participants had greater elbow flexion when polo drill swimming. And studies have shown that a greater flexion helps promote a greater propulsive surface on the upper limbs and helps position the hand to avoid slippage through the water. So polo drill swimming may promote this greater elbow flexion through the entry and catch phase of the stroke. Surprisingly, there were no significant differences in the swimming velocity and the vertical displacement of the finger and shoulder. And the hip velocity decreased, and this has been suggested to be caused by a decreased leg kick frequency. However, as the leg kick wasn't assessed in this current study, this parameter should be assessed in future studies in order to draw more accurate conclusions about the effect of leg kick on polo drill swimming. So this study aimed to determine how temporal performance variables and kinematic parameters might differ in the entry and catch of the stroke when polo drill swimming. Despite the obvious differences between freestyle and polo drill swimming, the upper limb kinematics were not significantly altered when polo drill swimming, and this may suggest that swimmers were able to maintain a consistent arm trajectory. So our initial findings confirm that polo drill swimming may indeed improve the hand position within the entry and catch phase of the stroke. However, before general conclusions can be drawn, future research directions are to investigate the entire underwater stroke phase using a larger sample size and more measured variables. However, currently, this pilot study demonstrated that kinematic and temporal parameters could be measured given the current setup, and creates a platform to further investigate the polo drill and also additional drills. Thanks for watching. For more details, you can have a look at the ISBS manuscript, or you can send me an email. Thanks.